Uh, yeah, you can get some. So, once again, we're showing numbers and quantities, and we're looking at properties of exponents. And the second standard is Math Practice Standard number 6, which is attend to precision, right? So, with that said, our objective is still the same as yesterday. We're going to continue on today. I can simplify exponential expressions using the multiplication properties of exponents. Tell your neighbor what concept we're still on. What concept are we still on? That is correct. Exponential expressions. Very good. So, what do we know once we know the concept? What do we do with that? Yes?
We put it in the little...
Put it in the little. Yes, in the little thingy. Write it inside the Ferrier model in the center, or some of you call it inside the box, right? So write it in there and see if you can remember the definition without looking at your notes. Exponential expressions. Write your definition. If you can't really recall right now, start writing examples. Maybe that'll help. Non-examples. Try and fill that in. I'll give you guys some time. Go. Okay, let's see. Definition. Exponential expressions. They are numerical or variable expressions raised to a power greater than 1. Hands if you got it spot on. Bam! Well, nice try for those of you that didn't. Examples. You can write any example, right? So some of the examples, we got 2 to the 3rd, x to the 6th, negative 3x to the 4th, x squared y cubed. None examples, so I wrote a couple over here. But what was the most important thing to remember about exponential expressions? They are what? Expressions. So they are expressions. And what else? Exponents greater than 1. Okay? Now that was the easy part. The next part, remembering the steps, was the fun-er part. We're not going to write them down, but I'm just trying to see if your noodle's already like, oh my goodness, I remember. Okay, so our steps, let's see. Step 1, identify if the exponential expression is a product of powers, power of power, power of product. Step 2, use appropriate property to compute. And step 3, simplify. So yeah, we don't need to write those, but we know these steps. Yesterday we did product of powers. We're not gonna, I'm gonna revisit it a little bit so that we can refresh in our memory, but we're gonna focus today on power, power, and power of products. Okay? So with that said, quick refresher. Yesterday I said whenever you see a variable or a number without an exponent, you're gonna write an exponent of 1. And I also introduced or refresh in your memory in regards to the commutative and associative property of multiplication. Remember that? And I said these properties were introduced ever since 3rd grade, by the way. You were introduced to distributive property, commutative property, and associative property. Okay? So, I gave you guys notes such as this. Remember that? And then once we understood the rule, we came up with our rule and we said asterisk, heart, when multiplying exponential expressions of the same base, add the exponents 10 cubed. Remember that? Yeah. Okay, so we got that. That was the product of powers property. So from there, we did these two. From there, we did these two. And I think we stopped there, right? So, copy these right underneath the Ferrier model. You have space right there where in the front, right? This is the Ferrier model, or the box. Underneath, you have space, don't you? Okay, copy those. You have 30 seconds. See if you can simplify those. You don't need to multiply them out at the end. Just write them as an exponential expression. Go. For A. Hands if you got 7 to the 12th. Thank you, that is correct. Volunteer for B. Who's got B? Yes?
I got
3 to the first, okay. Times 5 to the 10th power. Hands if you got that. Okay, and what properties did we use to get that? We first used the commutative, 3 to the negative 3 times 3 to the 4th times 5 to the 8th times 5 to the second. So far so good? Then we use the associative property. These two, what happens to these if they have the same base? We add 4 plus negative 3, that gives us 1. Associate these two, same base, 8 plus 2, that's 10. So far so good? Okay, so we got this. Do that one. Example C, m times n to the negative 4 times m to the 4th. You have 15 seconds. Go. Be nice. Let's see, Julia, what'd you get? M to the 5th power times n to the negative 4th power. Hands if you got that. That is correct. And how do we get that? By the commutative, m times m to the 4th times n to the negative 4th. Associative, and that's how we get this, and we bring this one down. Now there's one more step, because when we simplify, we're not supposed to leave negative exponents, but we're going to get there till I explain the next properties. Okay, as long as you leave it like that, we're fine. Okay, copy this next one down, please. It's got d, x times x to the negative 1 times x to the negative 3 times x to the negative 4. Copy that. See if you can simplify that. You got 15 seconds. Go. Okay, so now check this out. On this one, who saw that all these are negatives? But all of them are the same base, right? Yes. But in my noodle, this is what I see. I associate these, and I'm going to combine all the negatives first. This becomes x to the negative 8, and this is x to the 1st, so therefore x to the negative 7. You can do that, or you could have just gone all the way across, right? Okay? Questions, comments, autographs? No? All right. Let's continue. So now that we got this, this is where I want to get to. Pens down, eyes up here. Now, applying it to word problems. Writing utensils down, please. Look at the screen. Check this out. This one says, light from the sun travels at about 1.86 times 10 to the 5th miles per second. Now, here, miles per second, they're implying to use a rate formula. Who's used that in science, rate formula? Distance equals rate times time. Who's heard that before? Okay, you're going to be using that more this year. And here also in math, since we're going to be applying a lot of word problems. However, who notices that this is in scientific notation? 1.86 times 10 to the 5th. That's called scientific notation. Refresher from last year. But it says, it takes about 15,000 seconds for the light to reach Neptune. Well, first of all, this is not in scientific notation. This is in standard form. Do you guys see that? So if I was to write the rate formula, I'm sorry, the distance formula, we got distance equals rate times time. What was the rate? 1.86 times 10 to the 5th. There it is. And what was the time that it takes the light to reach Neptune? 15,000 seconds. Now, here goes a refresher from last year. First step, we need to change this into scientific notation so that it's all in scientific notation. So, from last year, your teacher showed you guys how to change standard to scientific and vice versa. Here goes a refresher. First step, we need to write this with a decimal times the base 10 and an exponent. Remember that? It has to look something like this. So the first thing is, take the decimal of the standard form number. This one has a decimal on the far right. Do you guys see it? No, you don't, because it's invisible. Now you see it. There it is. Does everybody see it? So now, we need to move that decimal so that we have a digit, only one digit on the left of the decimal. Let's see, 1, 2, 3. Now we have one digit on the left of the decimal. Who sees it? Yes, right? So therefore, if I was to write this as a decimal, I have 1.5, and I need to write it times base 10, whatever amount of times I move the decimal. How many times did I move it? 4. So this is times 10 to the 4th. Is it coming back? Yes. So if I was to give you another random number, such as I don't know, 230,000. Okay, there it is, 230,000. And I need to change that in scientific notation. Right away. Can you see the decimal over here? No. Now do you see it?
Yes.
Yes. So we need at least one digit on the left. How many digits do we have right now? 1, 2, 3, 4, 5, 6 digits. We only need one. That means I need to move this one over right there. Is that correct? So my scientific notation would be 2.3 times 10 to the what? Everybody got it? Okay. So now, yes. Base 10 is because that tells us that we multiply times 10 every time we move the decimal. So for example, what is 10 times 10? 100. That means to the 10 we add one decimal place. That's why we put a 1 there. What is 10 times 100? 1,000. Check this out. So that means 10 times 10 to the second power, because if I was to move this over how many times? Twice, and that's how we get that. Okay? So, any questions, scientific notation? So this is probably the only step that you need to really think about, how to change to scientific, because after that we can use the product of powers property. Everybody look up, please. Who sees something that has the same base? Do you guys see it? What has the same base? Do you guys see that the 10 is the same base as the other 10? So can I group these together? And the numbers together? Yes. So check this out. So what property do we use? Commutative and associative. That's when we group them. Are we there? And here all we have to do is multiply the decimals. You're good at that. And here if we use the product of powers property, what do we get here? 10 to the 9. So therefore we end up with 2.79 times 10 to the 9 miles. That's how long it's going to take to get to Neptune. Are we there? Questions, comments, autographs? Like I said, on your worksheet you're going to have one of these problems. So once again, what is the most important thing to remember? Changing standard form into what? Scientific. After that you can use the property. Yes, question?
We don't have to simplify it to like...
Right here, as long as you leave it like this, that's fine. Okay? Alright, so let's move on. I'm not going to give you another. What I want to get to is the power of powers property. Okay? But before I do, pay attention to this one. This one's going to go pretty fast. Like I said, this is the year of the Y. In the other years, they just had you memorize something, and that's it. Let me show you this. Now that we know the product of powers property, it says if they have the same base, what happens to the exponents? Add. Everybody agrees with that. Let me use numbers. 3 to the second times 3 to the 0 equals 3 to the second plus 0, which is 3 to the second. Agree with that?
Yeah.
However, if I multiply this one out, what is 3 to the second?
9.
That means that this one is 9, and this one is... Does everybody agree with that? Yes? Okay. Therefore, what is 3 to the 0? Last year they had you memorize it, but now let me show you with this proof. 9 times what is equal to 9? So, by using reasoning, here we're saying that this becomes this. But does it work with all the numbers? Let's find out. 5 to the second times 5 to the 0, that is 5 to the second plus 0, which is 5 to the second. Are we there so far? What is 5 squared? That means this is 25. That means this is 25. Are we there so far? So, 25 times what gives me 25? So what do you think? If I continue going, what would be the rule? Don't say it out loud, keep it to yourself. What would be the rule if I continue going? Tell your neighbor. Let's see, something simple. Noemi, what did your neighbor say? So, any number, for example, x to the 0 will become what? Let's see, 3 to the 0 became, 5 to the 0 became, so therefore this is 3 to the 0, 5 to the 0, x to the 0. Hands if you got that. So the rule would be any number to the 0 exponent is, does everybody agree with that? Okay, so now that we have that, let's move on. Okay, turn your paper over in the back, write power of powers property, way at the top above the frame. Power of powers property. Okay, and I want you to write example Q. Example Q. And then you're going to write open parentheses, 2 to the 3rd power. Get it? Raise that to the 4th power outside the parentheses. Underneath that, I want you to write open parentheses, x to the 2nd, close parentheses, and outside to the 5th power. And I'm going to write one more underneath, open parentheses, 3 to the 4th power, close parentheses, and outside to the 5th power. Just copy that, and I'm going to go over the power of powers property. Once again, I'm not going to give you the rule. You're going to have to come up with a rule, so pay attention. Here it goes. Pens down, eyes up there. Here it goes. Ready? Eyes on the screen. Power of powers property does this. Don't say it out loud. Keep it to yourself. Some of you, if you don't see it, talk it over with your neighbors. Okay, you finish copying right now. Pens down, eyes up here. Here it goes. So, some of you already have your rule, and yes, it does work. Now let me show you what this means. Here it goes. Inside of parentheses, I have 2 to the 3rd power. Is that correct? But when we have an exponent, that tells us to repeat whatever's inside the number of times the exponent tells us to repeat it. So I have inside 2 to the 3rd power. But how many times am I going to multiply times itself? 4 times. 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. Do you agree so far? This is that. Okay? Now, what product or what property do we know that we can apply to this? The product of powers property, which is what we did yesterday. Do they have the same base? What do we do to the exponents? 3 plus 3 plus 3 plus 3. Does that give us the same? Yes. So now, does that mean that I want you to do this for homework? No. The power of power property shows us a shortcut. You said that the shortcut was what? To multiply what? Exponents inside of the parentheses times whatever it's being raised. Is that correct? Yes. So therefore, this is what we call in math factored form. Factored form. Now, the reason I'm showing you this, because when you get to some problems that you have a doubt of what we got here, make sure you factor it. Or in other words, when in doubt, factor out. When in doubt, factor out. Tell your neighbor what to do. Copy that, please. So with that same idea, let's say you wrote this and you weren't sure that that was the answer. What would you do here? X to the 2nd times x to the 2nd times x times x to the 2nd times x to the 2nd. Same base, you add 2 plus 2 plus 2 plus 2 plus 2. Is that 10? Yes. When in doubt, factor out. Everybody got it? All right, so let's write our rule. Asterisk, Heart. Oh. When raising an exponential expression to another power, let's see, comma. Is this an exponential expression? Yes. Is it being raised to another power? Yes. Same here and same here. So what do? Bam! Multiply the exponents inside the parenthesis times, let's see if it fits, yeah, right here, the exponents inside. Oh, I already said inside. Outside, my bad. Yeah, I did that to see if you were paying attention. Times the exponents outside. 10 cubed. Pretty simple? Straightforward, right? Okay, so let's do some practice. Copy these down, please. See if you can do these by yourself. Example 4. Simplify. For A, we got parentheses 5 squared, close parentheses, to the 4th power. For B, we got parentheses 4 cubed, close parentheses, to the 0 power. 20 seconds. Go. Okay, this was 5 to the 8th. Hands if you got that. Okay, this one is 4 to the 0. Hands if you got that. And who went the extra step and said that it was 1? That is correct, because now we know the rule, right? Any number to the 0 exponent is 1. Copy this one. Okay, look at this one. C is parentheses x cubed times to the power of -5 times x to the 4th. Do this first, bring this one down, and do the next step. Go. Okay, here we go. I said I'm going to do this part first, so that became x to the -15. Hands if you got that. Then I said bring the next part down, but now what property are we using? The product of powers. Are they the same base? Yes. That means we're going to add these, so therefore we end up with x to the -11. Hands if you got that. Okay, good. Okay, copy this one, please. There you go. Example 5, we got simplify A, parentheses 3 to the 4th, close the parentheses to the 5th power, and B is 6 to the 0 power, raise that to the 3rd. Go. 20 seconds. Volunteer for A. We've got A. Oliver. 3 to the 20th power. Hands if you got that. Okay, and for B, everyone. 1. Everybody got it, right? Watch. Let me show you why. What is 3 times 0? 0. So any number to the 0 exponent is 1. Yes? Yes, it's a cube. All right. Okay, copy this one. Example 5C. It says simplify. Parentheses A to the 3rd, close parentheses to the 4th power, times parentheses A to the -2, close parentheses to the -3rd power. Once again, do it baby steps. Start with this one, bring that down, and then this one, bring that down, and then do your next step. Go.
I added.
Okay, here it goes. I said do it one step at a time, yes?
Yes.
Okay, so here we go. This one, we get a to the 12. Bring this one down. What is this? 3 times -2, that's a to the, using the product of powers property, we add the exponent, so this is a to the 18. Hands if you got that? Okay, good. All right. So, okay, so now that we got this, write power of products property. Last property for today. Write that down, please. Power of products property. And underneath, you're going to write example super cube. And then you're going to write open parentheses 2x to the 4th close parentheses to the 5th power. Just copy that. Don't do anything else. Okay. Writing utensils down, please. Now check this out. One thing that you should notice by now, everybody look up, look at the previous one. What do you notice inside of the parentheses? Only one variable or number, right? How about the previous one? Only one number inside of the parentheses. However, look at the one we're doing right now. What do you notice?
Number and variable.
Is a number and variable. So that means they're going to have more components inside of the expression. However, look at the rule. Here goes the rule. First step, I said whenever you see a number or a variable without an exponent, you write a 1. This becomes tell your neighbor what happened. Tell your neighbor. Copy that, please. However, let's see. For those of you that don't see it, here, let me be a little bit more thorough. Here it goes. Okay? If you still don't see it, when in doubt, factor out. So this tells us to write 2x to the 4th how many times? 5 times 2x to the 4th times 2x to the 4th times 2x to the 4th times 2x to the 4th. Let's see. Which ones have the same base? The 2, 2, 2, 2, 2. What are the exponents? 1, 1, 1, 1, 1. So we just add them, right? 1, 2, 3, 4. Is it 5? Yes. How about x to the 4th? Are they same basis? X, 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 x. Yes? 4 plus 4 plus 4 plus 4 plus 4. Is that 20? Yes. So what would you say the rule would be for power of products property? Think about it. What would be something that you would write? Share it with your neighbor. See what would be your rule. Okay, so the rule would be same as power of powers property, but we multiply what? All exponents inside times what? Exponent outside. 10Q. Fairly simple? Yes. All right, so for homework, finish up the entire worksheet. Yes, that's due tomorrow. Enjoy your homework, everyone. If any questions, I'll be here in the morning, or go to the YouTube channel. Have a good one, guys. See you guys tamales.